In this video, we're going to be faced with lots of fractions that have radicals in the denominator, and we're going to learn how to rationalize the denominator. What does that mean? It means to eliminate any radicals in the denominator. It's a proper way of writing fractions that have radicals. So I have a process. Again, it's not rules. This just seems to be a good process to make the least amount of mistakes. We're going to reduce the fraction if possible, simplify the radicals, that means take out perfect squares and cubes, and then we're going to do this new thing called rationalize by multiplying by what you need, and we'll get to that in a minute. And then sometimes we need to reduce again. So let's just take it from the top. Problem 1, we're going to look at square roots. You see we have a fraction and we have a radical in the denominator, and our goal is to eliminate any radicals in that denominator. So step 1, can we reduce that fraction? No. Can we simplify that radical? No. So what's this rationalize mean? It means what would you need to multiply the square root of 3 to have a perfect square? Well, if you remember from the previous video, if you have a square root, you're looking for two of a kind. So if I have 1 3, I need to have one more. So whatever I do to the bottom of a fraction, I'm going to do to the top. So what I've created in the bottom is a perfect square of 9, and on the top I have 2 times the square root of 3. So what is the square root of 3 times 3? It's just 3. Now we really could bypass this step if you wanted and go straight to, if you have a pair of 3's, it comes out of the radical, and then we would just multiply the top part. Let's look at number 2 and how can this be different. Number 1, reduce that fraction. A lot of people skip that step and go, oh, let's just multiply by the square root of 32. Then you have these huge numbers. No, let's reduce. First of all, two separate radicals could be viewed also as one large radical of the fraction. So that's what's going to allow us to reduce this fraction. What are 50 and 32 both divisible by? I think 2. 2 goes into 50 25 times, and 2 goes into 32 16 times. So I've reduced the fraction. Now let's simplify the radicals. Well, what is the square root of 25? Just 5. What's the square root of 16? Just 4. Now I don't need to rationalize the denominator because there's no more radicals, period, and I'm done. So again, reducing and simplifying can save you a lot of work. Right? Let's look at problem number 3. We have some letters now, but that's okay. The first step we want to ask ourselves is, can we reduce the fraction? Well, this is outside a radical, that's an inside, plus, and those can't mix. And also, even if they were underneath the same square root, you still could not reduce it. The next question is, can you simplify any radicals? Meaning, are there any pairs could you take out? No. So the third step is, I'm going to go ahead and rationalize, which means I need to multiply by what I need. So I need a pair because I have square roots. So I need another 2 and another y. Whatever I do to the bottom, I do to the top. Alright, so on top I have 3 on the outside and the square root of 2y there. And then here I've created a perfect square because I have a pair. So the square root of 2 times 2 is 2, and the square root of y times y is y. Very easy process. All right, let's look at problem number 4. Can I reduce? Again, since they're both under the square root, you could think about that as one large square root sign. I can reduce that. So let's see, 5 goes into 24 times, and I can reduce the x's. It would stay on the bottom, and of course that leaves me a 1, because just think about it, 5 goes into 5 one time, 4. So there is that 1 there. Then, can I simplify? Well, sure. The square root of 1 is just 1. The square root of 4 is 2. But that x still stays there, because remember 4 is 2 times 2. I have a pair of 2's that comes out, but that x is not a perfect square. So I've reduced, I've simplified, I still have to rationalize. Now be careful here. You just multiply by what you need to get rid of the radical. So we're looking at just this part. The 2 is already outside of a radical that's not needing to be rationalized. So what I need to multiply by is just the square root of x. That's going to create that pair. So on top, 1 times the square root of x is the square root of x. I keep that 2. The square root of x times the square root of x is just x. That's a really good example to show you go through all the steps, and if you do it in that same order, believe me, you are going to make less mistakes and it should be a little bit easier. Alright, we have 2 more just to kind of drill that in. Alright, so can I reduce this fraction? No. Can I simplify the radicals? Yes. The square root of 1 is 1. 12 we can break apart. So I have a pair of 2's, take it out and leave the 3. X cubed. I have a pair of x's, I can take that out and leave the x. Alright, so I didn't need to reduce, but I did simplify. That means take out things of the radical. Now I need to rationalize. And again, only need to look at what in the denominator is inside a radical. That's what you need to figure out. That tells you what you need to multiply by. So I only need to multiply by another 3 and another x. So on top I have the square root of 3x, 1 times the square root of 3x. On the bottom I have this 2x multiplied by 3x, because 3 times 3 is 9, the square root of 9 is 3, x times x is x squared, the square root of x squared is x. So let me clean that up. Multiply that together and I have 6x squared. I cannot reduce the 3 and the 6 because one's in a radical, one's outside the radical. So that's my final answer. Okay, let's look at number 6. Can I reduce that fraction? No. Can I simplify the square roots? Yes, I can. The square root of 49 is 7. Then the x cubed is just like what we did over here. I can take out an x and leave an x. On the bottom, the square root of 9 is 3, and y cubed is just like x cubed. You can take out a y and leave a y. Now we need to rationalize, and again, just looking at the part of the denominator that's inside a square root or a radical sign. What do you need to multiply by? Just a square root of y. So on top we have 7x times the square root of xy, all divided by this 3y. That y times that y under a square root comes out as a y. So we have this numerator, and on the bottom y times y is y squared. So once again, just multiply by what you need. No more, no less. Alright, so now we have cube roots. The process is the same. Again, I'm reminding you we need to reduce, simplify, rationalize, and maybe occasionally reduce again, but that is rare. Alright, so let's look at number 7. Can we reduce the fraction? No, 5 and 2 does not reduce. Can we simplify, meaning take out anything? No, we cannot. But what do we need to rationalize by? This is a cube root. Remember, a cube root, I need 3 of a kind in order to get rid of that cube root. So let me go ahead and write this as the cube root of 5 over the cube root of 2y, just so you can see that separated. So I have this. I need 3 of a kind. So what do I need to multiply by? I need to multiply by a cube root of a 2y and a 2y. Now just so you can remember, 2 times 2 times 2 is 8, y times y times y is y cubed, so the cube root of all of that is just going to be 2y. So remember, that's why we need that 3 of a kind. So when I have all of those multiplied together under a cube root sign, it just comes out as 2y. On top, all that's underneath the cube root sign, I need to multiply 5 times 2 times 2, which is 20, and y times y, which is y squared. I know I cannot simplify that because back here it's already factored and there's not 3 of a kind. That's my final answer. I cannot reduce it. 2 cannot go into 20. This is outside of a radical. This is inside a radical. Right? Number 8. Can we reduce 5 over 9? No. Can we simplify the radicals? Well, let's see. That's the cube root of 5. And this is the cube root. Let's go ahead and break that 9 down. 3 times 3 times y. Even though you're saying, yeah, but I know there's not 3 of a kind. Trust me. Go ahead and prime factor it out, because it's going to help you on step 3 by multiplying by what you need. Okay? Remember that we need 3 of a kind. Okay? So look at that one. Let's think about it. So I have 2 3's. I only need to multiply by one more 3 to give me 3 of a kind. But I have 1 y, so I need to multiply by 2 more y's. So look at what I've created down here. That would give me 3 times 3 times 3 times y times y times y. And for a cube root, that would give me 3 of a kind. That's going to equal just 3y in my denominator. Okay, so whatever I did on the bottom, I have to do to the top. Multiplying all that together, I have the cube root of 15y squared. Let me write that again. That's the cube root of 15y squared over just 3y. So that's really key. By multiplying by what you need, prime factored out, count, say I only need 1 more, 2 more. The 3 and the y are not glued together. Let's look at the last example. Remember, step 1, we ask ourselves, can you reduce the fraction? No. Step 2, can I simplify any radicals? Well, let's break it down and see. 2 and y, no. The 9 is 3 times 3, so I don't have 3 of a kind there, but what about x to the 5th? So you can use that short method of dividing the exponents, or the longer method, what I'm doing here is saying, okay, yes, I can take out an x. So I have the cube root of 2y on top, the x comes out, and on the bottom I have 3 times 3 times x times x. I'm going to go ahead and leave it in that factored form so I can do my third step of rationalize, meaning multiply by how many of what you need. So let's look at that. So I'm going to multiply by, I have 1, 2, 3, 1, 2, I need a third 3, 1, 2 x's, I need another x. So that's what I need to multiply by. So that gives me on top the cube root of not 2. Let's go ahead and multiply that together. What do I have? 2 times 3 is 6 times x times y. And on the bottom I have this x multiplied by a 3 multiplied by another x. So just to write that a little bit nicer, that's 3 x times x is x squared. So the cube roots are a little bit trickier because you have to know you need 3 of a kind, whereas the square roots you're just looking for a pair. But again, reduce, simplify, rationalize, and occasionally you might have to reduce the fractions at the end.